Alright, 7.2 Compound Angle Formula. A compound angle is an angle that is created by adding or subtracting two or more angles. So we can use a formula to be able to derive certain compound angles that normally we weren't able to find exact values. So we're going to do that in this section. Also, we're going to be looking at 7.1 as well in this section. But here are your compound angle formulas for sine, cosine, and tan, known as CAF for short, CAF, CAF. Sine of a compound angle is equal to sine A cos B plus cos A sine B. So this is what it is right here. This is if you have sine of the sum of two angles. If you have subtraction of two angles, all you will do is literally change the sign that's here. So again, if you have sine A minus B, you will take this and subtract the two parts. Now, cosine of the sum of two angles, you will have this. Cos A plus B is equal to cos A cos B minus sine A sine B. So again, for cos, you're going to have different signs. So if it's A minus B, then you're going to have cos A cos B plus sine A sine B. Now, what about tan? Well, tan is going to... Alright, tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B. Now, if you had a minus over here, it will change the signs inside the expression there, exactly as shown. So here is the CAF rule for sine, cos, and tan of compound angle formulas. Alright, we're going to also do 7.1 as I mentioned earlier, so let's keep moving forwards. Example number 1, you're asked to prove equivalent trigonometric functions in 7.1 using the CAF rule. So we're going to prove them. So I'm going to show you examples. Here we go. Tan of pi minus theta. So pi minus theta would be this angle right here. Pi minus theta, in terms of from standard position, would be this value right here. So pi minus theta would equal this terminal arm right here. What does that equal? Well, that equals tan of 2 pi minus theta. The reason why it was equal that is 2 pi minus theta is this angle. Alright. What you note is that in both of these quadrants, tan would be negative. So the final result will equal negative of tan theta. So you know that if I knew what the theta was, tan of theta would mean if theta was an acute angle, it would be in the in the first quadrant, and then the value will be negative because we're looking at terminal arms in both the second and the fourth quadrant. So these are all equivalent. Now let's prove this using a CAF rule. Using a CAF rule, this is equal to tan pi minus tan theta over 1 plus tan pi tan theta. Well, tan of pi, you should note, is 0. So tan of pi is going to be 0 minus tan theta. And then on the bottom, you will have 1 plus 0 times tan theta, which is just 0. What are you left with? Well, folks, you're going to be left with negative tan theta. So I'm able to take this and prove using CAF rule that it actually equals this. Try and prove this one by yourselves, and you will see, lo and behold, folks, that it will also equal this, because tan of 2 pi is the same as tan of pi, folks. So I could replace each of these with 2 pi, and I guarantee we will end up negative tan theta. All right, let's move forwards. Example number 2. You're going to ask to prove that sine 5 pi over 6 is equal to sine pi over 6. In the previous unit, you were just told, okay, second quadrant, the signs are positive. Therefore, the related acute angle is equal in the first quadrant is equal to the related acute angle in the second quadrant because sine is positive in both of those. Well, we're going to prove this now. And we're going to use compound angle formula to prove it. Well, what is 5 pi over 6? 5 pi over 6 is equal to pi minus pi over 6. So 1 whole minus 1/6. And that's the left side that we're looking at here. So sine pi minus pi over 6 using the CAF rule is going to equal sine pi cos pi over 6 minus sine pi over 6 cos pi. All right, so why do we have these drawings over here? Well, this is the sine curve right here. This here is your cosine curve. We need that to be able to determine the value of sine pi and cos pi. We also need the special angle pi over 6, special triangle with pi over 6. The special triangle of pi over 6 is going to be 1, 2, root 3 as such. So we need to evaluate sine of pi. Looking at the sine function, sine of pi will be this value right here. That equals 0. 0 times anything is 0, so we left it as 0. Minus sine pi over 6. Pi over 6, sine of that is 1 over 2. That's this value here. And times cos pi. Let's look at where cos pi is. Cos pi is going to be down here. What's the value of cos pi? Well, that is -1. So we plug in -1. And now we're going to expand it, and we get 1/2. So what do we see over here? Is that sine 5 pi over 6 is equal to 1/2. Well, let's check sine pi over 6. What is that equal to? Well, on the right side, pi over 6 is equal to 1/2. We already see that here, 1/2. So left side is equal to right side. Why do we do this? Well, guys, you were told this in the last unit, but here I'm proving to you, using compound angle formula, that you know what? This is true, and there's the proof that it's true. All right, let's move forwards. Example number 3. Prove that sine theta is equal to cosine of pi over 2 minus theta. This is known as a cofunction identity. So we're going to prove this cofunction identity. This is something that you can use. It's not necessary because you actually can prove this. But let's look at this anyways. Sine theta is equal to cosine of pi over 2 minus theta. That means, let's look at the right side and manipulate the right side. This, we can expand it using the CAF rule, which is cosine pi over 2 times cosine theta plus sine pi over 2 times sine theta. So what do we need, folks? We need the sine graph and the cos graph to figure out the pi over 2. Pi over 2, we will look at the actual curve. Pi over 2 for cosine is going to be this value right here. Cosine of pi over 2, cosine of 90, is equal to 0. 0 times anything is still 0, folks, so we only have to write that. Then we have plus sine pi over 2, so looking at the sine graph, pi over 2, the value is up here, which is 1 times sine theta. What does this equal? Well, this equals just straight sine theta. Looking on the other side, oh, look, here it is, folks. That's right. Right side equals left side, and we've now checked that this cofunction is actually true using the CAF rule. Here's another one. Example number 4. Here's another one of the CAF rule. So I'm just going to show it to you and show you how it's solved. Okay, it's the exact same way as we solved the other question, but this time we're expanding a sine, and we're using all the values to get this value. This makes sense. This is exactly like the previous one. All right, so again, we expand the sine using the CAF rule, we expand it, find the value of sine pi over 2, cosine pi over 2, we get the value of cos theta. Next, example number 5, you're asked to prove that this identity, cofunction identity, And here's the solution. Okay, we took the right side, converted it using reciprocal identity, and then I take the tan function and I calculate the values. Okay, and now when I use the tan expression, tan pi over 2 is undefined. So these now are undefined, folks. So this is where it leads us into trouble. What do you do when you have undefined? Well, it's tan, folks. So what can you convert tan to be? That's right. Using the quotient identity, you could have converted the cotangent right away to cos over sine, and this tan to sine over cos. If I converted to cos over sine, I would have gotten the following. Okay, so now what I did here, though, because I didn't, is I'm converting everything in terms of sine over cos for a tan. And this is what I get. So this is all of the function. What am I doing here? Well, I want you to look carefully. I converted everything in terms of sine over cos. That's what I did here. And the bottom is this in terms of sine over cos. Find a common denominator, which is cos pi. So this is the common denominator. So I get cos pi over 2 cos theta plus sine pi over 2 sine theta. And multiplied by the flip of this with the common denominator. So this is my common denominator and the numerator now. And my numerator becomes my denominator. And what happens is these coses will cancel. And you will end up with a value of the following. Okay? And that will give you tan theta. This seems complicated, and it is. If you hold on, I can show you how you could have approached this question a little bit faster and be able to prove it. Hold on. Okay, let's re-examine this question again. We're going to look at this tan theta and cotangent theta in terms of sine and cos. For example, the left side is equal to sine over cos, and that's what we have over here. And that is because of qi. Now, the right side is equal to cotangent of, so cotangent is cosine of pi over 2 minus theta over sine pi over 2 minus theta. Okay, and that is using qi and ri. Okay, reciprocal identity for cotangent and qi to convert it to sine and cos. Well, how will that help us? Well, we can take the right side now, folks, and manipulate that right side. The right side, using the CAF rule for that, the numerator will be cosine pi over 2 times cos theta plus sine pi over 2 times sine theta. And on the bottom, we can convert that to be sine pi over 2 sine theta minus, let's try that again, one sec. Let's recorrect, so the correction is sine pi over 2 cos theta minus sine theta times cos pi over 2. All right, so what will that equal? Well, cos pi over 2, if we remember the graphs, so we go back and look at the graphs, we can see this value. Let's move on to the next video to finish this off.